Hi everybody. So I'm trying something different for this lesson. I'm going to try and create the video through PowerPoint, and if this works, this might be a better way for us to proceed through the lessons. This one's going to be more of an experiment than anything else. Let's just see how this works. So here's a bit of a review of the material that I've already covered in the previous video about conductors. So I'm going to zoom through the first couple of slides here really quickly. This is the material that I already covered. 4 factors determining the resistance of a length of wire: type of material, diameter, length, and temperature. The next slides just go through the same conversation. Type of material. There's a list of resistivity of materials, temperature coefficient. I mentioned temperature. We're going to look at these numbers a little bit more later. I just want to zoom through here for now. Diameter matters. Length matters, and I actually made an error here on the previous video. I said that higher temperatures reduced the resistance. Notice this says most conductive materials will increase their resistance with an increase in temperature. For me, that's a little bit counterintuitive, but the science is what it is. That's the information. So this thing called coefficient of temperature is a little bit of math that we will have to do when we get there. The reason that I wanted to provide you with these PowerPoints, if you've already gone through them, you've noticed that there's a little more information here, and I did want to just speak to it quickly. The fact that there are different types of conductors, and we will be referring to different types, doing math on different types, so it's important that we cover this material. First of all, round conductors, obviously, that's what we think of initially, but even within that family, there are many of different options. So bunch stranding, these little wires here, we see that the conductor is actually made up of many little tiny conductors, and they're not organized in any way. They're just bunched together. Okay. On the other hand, concentric spiraling is much more typical. So this kind of look is much more typical for a stranded conductor. Okay. Or even what's called a rope strand as well. So let's look at some of that. So solid wire first and foremost, but then stranded wire more typically, and there are different sort of categories, if you will. So the first is a standard stranded conductor, which has 7 strands. And here's the way that it's configured. So you have 1 strand in the middle, and then you have 6 strands that are concentrically spiraled around it. All right, so that's the standard formation of a 7-strand standard stranded wire. Whew. You got all that? On the other hand, maybe if we expand that out, we could have 19 strands. And in this case, and it starts to get hard to look, but here's our 1 in the middle and our 6 wrapped around it. And then we have an additional layer, which gives you a total of 19 strands. And then we can get really carried away up to 37. And again, it's the same thing. We've just added 1 more layer around the outside. Okay, so there's our stranded conductors as compared to the solid wire, and we are going to spend time dealing with these different constructions. Okay, and then finally, we have to also understand that there are square conductors. Okay, so this in this substation environment, we actually have large bars of copper, which are conductors, and they are square, not round. They may also be solid, square, or rectangular, or even hollow in some cases, although we're not going to get to the point where we do math on that, but understand that that's possible as well. Something this large, this is probably not solid. This is most likely hollow. Okay, so that's just a quick introduction to the fact that there are many different types of conductors, which is really the underlying reason for a lot of the math we have to do coming up really soon. So I'm going to get the next lesson up and running as well. I just wanted to finish off this lesson before moving on to the next one. Let's see how this video works out, because now I've got my work cut out to me to see if I can publish this and post it. Be back soon.